Okay, so I'm going to help you to gain a better understanding of endothermic versus exothermic reactions. So I want you to think of these terms in two categories: physical changes versus chemical changes. And hopefully that will clear up some of your confusion. So go ahead, get a sheet of paper, pause the video, get a sheet of paper, get a pencil. Grab a ruler if you are OCD about straight lines like I am. So pause the video. All right, now that you're back, let's go ahead and we're going to just draw a straight line down the center of the paper. Doesn't matter if it's perfect. And we are going to draw a line close to the top here going across so we can separate and create the graphic organizer. Now on the left-hand side of the graphic organizer, we are going to write physical changes. On the right-hand side of your graphic organizer, you're going to write chemical changes. So now let's go through and kind of review what these terms mean, because it's been a while since you've seen them. Although we say them and still use them throughout our lessons, it's just been a while. Physical changes are what? You're correct. Phase changes. So the phase changes that we've talked about so far are those that happen with water. So water can occur in three different forms, correct? Yes. Liquid, solid, and gas. So we just call liquid water water. We call solid water ice. And we call water in a gas form water vapor. Some of you may even say steam. So when I talk about the phase changes, that's what I'm talking about. The different phases that a substance can exist in, liquid, solid, or gas. So I'm going to just list that here: solid, liquid, and gas. And we're going to go through and talk about those. Do you guys remember the names of the phase changes? Melting, evaporation, condensation, freezing. We didn't really get into sublimation and deposition because that would have required us to use a substance like dry ice to demonstrate that. We'll talk about those later. But for today's purpose, we're going to focus on four: freezing, evaporation, condensation, and melting. Now, on this side of your graphic organizer where you wrote chemical changes, we're talking about those types of changes that produce totally new substances. Like when you mix two reactants together and you form totally different products that are different from the reactants. They look different, they smell different, they behave different. So these are chemical reactions. When I talk about chemical changes, I'm talking about chemical reactions. These are different from physical changes because even when water becomes ice or water vapor or liquid water, it's still what at the end of the day? Water, you're right. However, when a chemical reaction takes place, such as mixing baking soda and vinegar, at the end of the reaction, you're going to produce carbon dioxide gas and you're going to have a whole bunch of water left in the beaker. So you're forming two totally new substances as a result. So because of these fundamental changes in physical changes versus chemical changes, we're going to use the terms endothermic and exothermic a little differently. So let's go ahead and see what I'm talking about when I say we're going to use them differently. So let's talk about how we use the word endothermic when we talk about physical changes. So I'm going to write endothermic. I want you to write it as well on your paper. And I'm going to put a box around it. Two of the phase changes that we discussed earlier are going to be endothermic. So let's think about that. Endo means in, absorb, taking something in. Therm means heat. So what are we taking in? We're taking in heat energy. So which two phase changes requires the absorption of heat in order for them to happen? Well, I think when I melt ice, I need heat in order to do that. When I boil water and cause it to evaporate, changing it from a liquid to a gas, water vapor, that requires the input of heat energy from the stove, right? Yeah, we did that one in our virtual lab. So I'm going to draw two arrows from the word endothermic on the physical changes side, and I'm going to write the word melting, and I'm going to write the word evaporation. Because these are the two phase changes that requires the input or the absorption of heat. Now, when we discuss melting, we're talking about a solid becoming a liquid. So going from ice to water. When I talk about evaporation, I'm talking about a liquid turning into a gas. So that's liquid water turning into vapor, or what you guys call steam. Okay? These processes absorb heat energy. So let's write that right here. They absorb heat. Now I know you're wondering, Ms. Hutchins, you told us that the surroundings of an endothermic reaction should be cold. Well, when solid ice becomes liquid, the liquid isn't as cold as the ice, and that's true. The surroundings will only become cold when we're talking about endothermic chemical reactions, not for endothermic physical changes. Okay? So I hope this is starting to come together for you. Now let's talk about exothermic processes under physical changes. We talked about endothermic, so now let's break down exothermic. So if two of the phase changes we talked about were endothermic, then the other two are going to be exothermic, where we release heat in order for these processes to take place. And those processes are going to be, you said it, freezing and condensation. So let's talk about what happens in freezing and condensation. So when something freezes, we're taking a liquid and we're turning it into a solid. So that's where water becomes ice. Condensation is where we take a gas, a hot gas, water vapor, and we cool it off to turn it back into liquid water. These are the little droplets of water that you see on a glass. These are the droplets of water that you see on your grass in the morning that we call dew, morning dew. These are condensation droplets. So in order for this to happen, we have to release heat. Okay? So heat is released in order for freezing and condensation to happen. So that's how we use the words endothermic and exothermic for physical changes. Now let's come over here and explore how we're going to use these two terms, endothermic and exothermic, when we talk about chemical changes, okay? So for chemical reactions, when I am using the word endothermic, and I want you to also refer to the notes that we took together that day under the document camera, if you can recall, when we drew the reaction coordinates. For, excuse me, for endothermic reactions, I believe we drew a graph that on the y-axis we had energy, and on the x-axis we had reaction pathway, right? And we drew 3 sets of dotted lines so that we could show what's happening. These types of reactions require a lot of energy to get started. They're not spontaneous. They take a minute because they have to absorb heat energy from their surroundings in order for the reaction to happen. So they have a high activation energy that's required. So the reactant's energy level starts here at the bottom, goes to the max line, and boom, to produce the products. So I'm going to draw R for reactants and P for products. So that's what the reaction pathway would look like for an endothermic reaction. Now, the reactants, like I said, they absorb heat from the surroundings. So you're going to draw an arrow showing that heat must be absorbed by these guys. Now, because heat is absorbed from where? From the surrounding area. So imagine right now in your room where you're standing, if you were to suck all of the heat out of your room into a little box, how would that make your room feel? Cold, you got it. So in these types of chemical reactions, endothermic chemical reactions, the surroundings are going to feel cold. And why do they feel cold? They feel cold because these greedy little reactants right here sucked up all the heat energy from the surroundings in order to make their products. They absorbed all the heat energy from the surroundings. So the temperature of your surroundings drops. It becomes very low. Low temperatures means cold. It feels mucho frío, very cold. Now, we're going to talk about exothermic reactions, and that'll conclude our lesson here. So, exothermic chemical reactions. Let's draw the reaction coordinate again. So, energy on the y-axis and the reaction pathway on the x-axis. Draw your 3 sets of dotted lines. They don't have to be perfect. Now, these reactions, because their reactants already contain so much heat energy, these reactions are going to happen spontaneously. Think about the Coke and Mentos. Think about the elephant toothpaste. As soon as I added the yeast catalyst to the elephant toothpaste experiment, what happened? You're right, foam just rose up, exploded out of the Erlenmeyer flask and the graduated cylinders. Think about the Coca-Cola and Mentos experiment. Soon as I added the Mentos, what happened? Yeah, we got this big volcanic style eruption of Coca-Cola through the top of the bottle. So those reactions are what we call spontaneous because their reactants have high amounts of energy waiting to release that energy to the surrounding environment. So those reactants are going to start off at the high energy mark, peak, and then the products are going to be down here at the low energy bar. So I'm going to draw R for reactants up top and a P for the products that are produced. And I'm going to draw an arrow going away from the reaction, showing that heat is released. And it makes sense. Exo means exit. Therm means heat. So exothermic reactions are the ones that release heat to the environment. So heat here is released, which means how are the surroundings going to feel? Imagine you're in your room right now. You have this little box. The box is very hot. There's a lot of heat inside that box. All of the heat is going to escape the box and go into the surrounding environment of your room. How's your room going to feel? Man, it's time to take your jacket off because it is hot in here. You're right. Once heat is released by the reactants to the surrounding environment, then the surrounding environment becomes cold. It becomes hot. So, surrounding feels hot. And the temperature on your thermometer goes up. High temperatures means that something is hot. So I hope that this little session helped to clear up any of your misconceptions about endothermic and exothermic as I separated the terms into 2 different categories. physical changes and chemical changes. They do mean the same thing in terms of the reactants and what the matter is doing in each process here or each reaction here. However, what happens to the surrounding environment is a little bit different when we're talking about physical changes versus chemical changes. So review this video as often as you need. Make sure you write down the notes from the video. I'm going to take a picture of these notes and post it in our Canvas classroom for further help. All right.